Have you ever looked up at the night sky and felt that deep cosmic sense of wonder? That feeling that there's so much more to reality than what we see? Well, you're not wrong. Today, we're diving headfirst down the rabbit hole, past the familiar world of atoms and molecules, into a realm where the very fabric of space and time gets wonderfully weird. Welcome to the world of quantum dimensions. All right, let's start with what we know. We live in a world with three spatial dimensions: length, width, and height. Up, down, left, right, forward, backward. Simple enough. Then, Einstein came along and blew our minds by adding a fourth dimension: time. He showed us that space and time are woven together into a single fabric called space-time. Think of it like a giant, stretchy trampoline. A massive object like the sun creates a dip in this trampoline, and planets like Earth are just rolling around in that curve. That's gravity, but here's where it gets wild. What if that's not the whole story? What if there are more dimensions, curled up so tiny that we can't perceive them? This isn't just science fiction. It's a core idea in one of the most ambitious theories in physics, string theory. String theory proposes that the fundamental building blocks of the universe aren't point-like particles like electrons or quarks. Instead, they're unimaginably tiny, vibrating, one-dimensional strings of energy. And just like a guitar string can vibrate at different frequencies to produce different musical notes, these tiny cosmic strings vibrate in different patterns to create everything we see, all the particles, all the forces. An electron is one note, a photon is another, and so on. We're all part of a grand cosmic symphony. But for this symphony to work, for the math to line up and explain our universe, string theory needs something extra. It needs more dimensions. Not just one or two, but a whopping 10 spatial dimensions, plus one time dimension, for a total of 11 dimensions. So the big question is, where are they? Why can't we just take a step sideways into the fifth dimension? Well, the theory suggests these extra dimensions are compactified. Imagine a tightrope walker. From far away, the rope looks like a one-dimensional line. They can only move forward or backward. But for a tiny ant on that same rope, it's a whole different world. The ant can move forward and backward, but it can also crawl around the circumference of the rope. That circular path is a hidden, curled-up dimension. That's the idea with quantum dimensions. They're curled up into incredibly complex shapes known as Calabi-Yau manifolds. These shapes are so tiny smaller than an atom by orders of magnitude that they're completely invisible to us and our best instruments. Yet, the specific shape of these hidden dimensions is incredibly important. The way they're folded and twisted determines the exact way the strings can vibrate. This, in turn, dictates the fundamental constants of nature, like the strength of gravity or the charge of an electron. If these dimensions were folded just a little bit differently, the laws of physics could be completely different, and our universe might not even exist. Now, let's talk about time. We experience it as a one-way street, always moving forward. The past is gone. The future is yet to come. But in the quantum realm, even time gets fuzzy. One mind-bending concept is called quantum superposition. It means a particle can exist in multiple states at once until it's measured. Imagine an electron spinning both clockwise and counterclockwise at the same time. Could time behave this way? Some physicists speculate about a block universe model, where all of time past, present, and future exists simultaneously. Time doesn't flow. It just asterisk is asterisk. Our consciousness simply moves through this block, creating the illusion of a flowing river. In this view, the past isn't gone, and the future is already written. It's a challenging idea, but it's a potential consequence of weaving quantum mechanics with relativity. Another fascinating idea is the holographic principle. It suggests that all the information contained in a volume of space like this room, or the entire universe, can be described by a theory on the boundary of that space. It's like a hologram. The three-dimensional image you see is entirely encoded on a two-dimensional surface. Could our 3D universe actually be a holographic projection of information stored on a distant 2D surface? This idea emerged from studies of black holes, and it could completely change our understanding of what space even is. It suggests that space itself might not be fundamental, but an emergent property of something deeper. So, how do we test any of this? That's the billion-dollar question. Scientists at places like the Large Hadron Collider are smashing particles together and near the speed of light, hoping to see evidence of these extra dimensions. One possibility is that some energy from the collision might leak into these hidden dimensions, showing up as missing energy in our detectors. So far, we haven't found definitive proof, but the search continues. Another avenue is by looking at gravitational waves ripples in spacetime. Perhaps these waves carry subtle signatures of extra dimensions that our advanced detectors could one day pick up. These ideas, tiny vibrating strings, hidden dimensions curled up into complex shapes, time as a block, and our universe as a hologram stretch the limits of our imagination. They show us that the reality we experience is just one thin slice of a much larger, more complex, and frankly, more magical cosmic structure. We're like fish who have spent our whole lives in a pond, only just beginning to realize that there might be a vast, unseen world of land and air just beyond the water's surface. The journey to understand these quantum dimensions is one of the greatest adventures in human history. It's a quest to answer the most fundamental questions. What is reality made of? And what is our place within it? The answers might be hidden in dimensions we can't yet see, but the search itself is expanding our own. Thank you so much for joining me on this mind-bending journey today. If you enjoyed exploring the strange and beautiful world of quantum physics, please hit that like button and subscribe for more deep dives into the cosmos. Let me know in the comments what part of this blew your mind the most. Until next time, stay curious.